So in this final part of the unit, I'll just go and reiterate some of the things about good strategies for avoiding bugs as you write your own code. So, as I said at the end of the last part, the thing really to go and do is try to not just jump into immediately writing code, but do some work thinking about and planning how your code is going to work. So maybe start by sketching a flow diagram or a simple description. Don't worry about trying to write it in correct code. Just think about writing it in simple English to go and describe what your function, what your code should go and do. Split it down into its various small sections of working code. Those will tend to end up being functions. If it's too much, too complicated, then split it down again and split it down again into subtasks and sub-subtasks and so on. So for more complicated logic, try to write out some rough code on pen and paper first. Again, don't worry about the exact Python syntax, you can fix that later. Start by just thinking about the logic of how you code that. Think carefully about what each task or each subtask is doing, and think about and analyse what does it need to take in and what does it need to produce. And those become your inputs to your parameters, the inputs to your functions, your parameters, and they become your return type. And pretty much you should be able to get to the point where you can write down your code in terms of a series of function names and the doc strings without any actual code there yet that does anything, just by thinking about what does it need to go and take in, what does it need to go and produce. And then you can start turning that into individual functions. So, as I've said many times, write the doc strings first. It will really seriously help you keep your code straight as you do that. So there are things for good design. So it's partly a matter of style, but it's not an exact science, it's maybe more of an art, but at least here are some of the points that I would consider all the time. So always ensure that the data that the function needs is passed in as a parameter. So I said this when we were talking about in the previous parts about the fact it was relying on, one of the functions was relying on a variable that was defined outside the function. That's a terrible idea. Do not go and do that. Make sure your functions do one and only one thing. If you can't express what that function is going to do in that one line at the first line of the doc string, it's probably telling you that function is too complicated, it's trying to do too many things, and you should split it up into several smaller chunks. And kind of related to that, try to keep the number of lines of actual code, so not doc string, but actual code of your function, small enough that it fits on your screen, or maybe 2 screenfuls in one go. Very long functions are almost certainly likely to be better written as a series of shorter functions that can then be built together to give you a more compact final function. And the other strength about doing this, if you work in this sort of way and you split things into lots of small functions, ideally you make it so you can test each of them individually and make sure that something is working. One of the things that we see quite often with students programming is they write a lot of code and then they try and run it all. And that's a mistake, because it's almost certainly going to have bugs. We always introduce bugs in our code. And trying to debug 1,000 lines of code in one go is really hard. It's much, much better if you go and start off by writing just one function at a time and think, how do I test this? What do I put into this to make sure it's going to give me the right answer, to check that it's working? So write a function and then think about how do you test to make sure it's the right thing. Then write the next function and test that. Then test the 2 functions working together. And build your code up like that. It might seem a long-winded way, but in the long run it's going to be a lot quicker than trying to reverse engineer and debug everything. So, as I was saying, test early, test often, and try to come up with all those simple tests you can do. With bigger projects, you're going to group functions together into modules, and if you look at the Unit 4 of the Structure Your Code section, that'll go and discuss how modules are done, and I'll explain and introduce you to this guard clause that we can put in. The purpose here is to, if you're writing a file full of functions that's going to be part of a bigger program, you probably also want to include some tests of those functions as you're writing them and as you're developing them. And this construct here, this allows you to have code that you're going to run only when you're when you're testing your module, and that's not going to interfere with how the module works when you're importing it into other code. So in our code, down here I've put a if __ name equals __ main colon. This clause here, this is designed to stop these lines under it from running if I try importing this code, and it'll only run if I tell it to run the code. So for all the details about what's going on there, have a look at the video tutorial in Unit 4 of the Structure Your Code examples about how to write modules. So this is an example of how we've done that. That's also the same as I've just shown you. So simple tests like this will go and help you verify that your code is working correctly. There are actually all kinds of both things built into Python and also third-party packages that provide a whole framework for writing tests. That's beyond the scope of this course, but just so you're aware that writing tests for functions is a very useful and very important way of verifying that you've actually written code that does the right thing. The final thing I want to just go and say is about commenting. So as well as writing docstrings into your functions, another very useful thing is to put comments in. And comments are notes to yourself, or indeed somebody else has got to maintain this code, as to things to pay attention to. So a docstring purpose is to tell somebody else how to use your function. A comment is to you or somebody else who's maintaining or writing that function as to what is really going on inside it and what the limitations, where there might be things to come back to. So again, if I go back to the code we were looking at there, I've put some comments in on these functions. So you see I've got to-do comments that make a note that says, yes, I've realized that I've just made an assumption here. I've assumed that the kernel is positive and I should put in some code to deal with what happens when it's negative. And actually you'll see that Spider has given me a nice little tick because it spotted I had a comment with to-do in it. And there's another one down here, which is a note to myself as I was coding this saying, well, why have I made these in integers? Surely floating point coefficients would be fine as well. And then the other place I tend to put comments in is where I've got branches or loops, anything which is not, I just need to explain to myself what it is that I'm trying to do here. So I've both got one on the loop and I've got one on the if statement here. So those are kind of examples of where I would go and use a comment to help explain to myself what I was thinking about, what my code was trying to do. So that is a walkthrough of the various things you can go and do to try and debug your code and make sure that you minimize the number of places where you can introduce bugs into what you're doing.